Good day, students. So welcome to part 3 of the Algebra 1 Common Core Regents exam for fall 2013. In this installment, we are going to be going over problems 6 through 10. All right, let's take a look at number 6. It says Riker is given the graph of the function y equals 1 half x squared minus 4. He wants to find the zeros of the function, but is unable to read them exactly from the graph. So this is a graph right here of the function 1 half x squared minus 4. So if you look at this graph, can you identify where the zeros of the function are? Zeros of a function are the points on the graph where um, the graph intersects the x-axis. Okay? So do you see that? The zeros of the graph of this function are located here and here. All right, so those are the two zeros right there. Well, the problem is they're somewhere between, the first zero is somewhere between 2 and 3, and the other is between -2 and -3. So do you see what Riker's problem is, or his complication? It is because the graph doesn't intersect whole numbers, it intersects a, um, a decimal, basically. All right? So since this cannot give us an exact result, and that's what we want, an exact answer, we have to resort to another method. So we are going to have to use a different method to find the zeros. Okay, so in order to find the zeros, let's extract the function. We have y equals 1 half x squared minus 4. To find the zeros, as the name indicates, we're going to set the function to 0. So 1 half x squared minus 4 equals 0. We're looking for the x values that will cause the function to have an output of 0. Because if you look at this function, when the graph hits the x-axis, the y value is 0, there and there. Okay? So what x values will cause the y value to be 0? That's what we're looking for. Okay? So let's solve this function by factorization. Actually, we don't have to factor. Let's just use algebra to solve it, even though we can solve this by factorization. So first thing we're going to do is get rid of the -4. So to do that, we just simply do the opposite of -4, which is add 4 to both sides. And that yields 1 half x squared equals +4. All right, now how do we get rid of this 1 half? To do that, we're going to multiply both sides by the reciprocal of 1 half, which is 2 over 1. So multiply this side by 2 over 1, and then multiply this side by 2 over 1 also. All right? So these two 2's divide out. On the left side, you're left with x squared equals 4 times 2 is 8. Now, to get x isolated, we're going to take the square root of both sides. All right? Anytime you take the square root of a square, you have x equals plus or minus the square root of 8. So the question now is, are we done? Remember, we are asked to find the zeros in the simplest radical form. So in order to answer the question if we're done or not, we have to answer the question about this result. Is it in its simplest form? In order to simplify this or ensure if it's in its simplest form, we have to break it down into its prime factors and ensure that we don't have any repetition of factors for 8. Okay, so let's break this down. Take out 2. 2 goes into 8 4 times. Extract another prime factor, 2. 2 goes into 4 2 times. So look at the factors of 8. 2 times 2 times 2. Do you have any repetitions happening here? The answer is yes. So you notice that these two 2's repeat, so we can take the square root of 2 times 2. So what is the square root of 2 times 2? The square root of 2 times 2 is 2. Okay? So these two 2's, since they repeat, they come out of the square root as a 2. But this 2 is by itself, so it remains behind. All right? So root 8 can be simplified into 2, which is the square root of 4. And you're left with the other 2 as a radicand. So the simplified form is going to be x equals plus or minus 2 root 2. So these are the zeros of the function. So let's put them in our calculator to see, to get a better understanding of the significance of this answer. So negative 2 times the square root of 2, enter, 2.82. Negative 2.82 is this 0 right here. You see it's very close to negative 3, so this is negative 2.82. And the other one is going to be the opposite of that, 2 root 2, which is 2.82. All right, so let's go ahead and write that down. This 0 right here is negative 2.82, 2.828. We weren't asked to do this. I'm just illustrating the situation for you. And then this is 2.828. All right, but the exact answer that we're asked to find is this is our answer right here. I just wanted to show you that our answers are in fact correct. Let's say you got some answers and then you plug them into the calculator and they don't fall in here, then that means that your answer is basically incorrect. All right. Okay, let's move on to problem 7. In problem 7, it says Emma recently purchased a new car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. The results are shown in the table below. So we have this results right here. It says write the linear regression equation for these data where miles driven is the independent variable. And we have to round all our values to the nearest hundredths. Okay, so in order to answer this question, we're going to have to make use of the graphing calculator. We're going to be using a TI-83 plus to do this problem, as you can see. And this is the outline of the steps that we're going to be using here. All right, so let's go over this real quick. So first thing you're going to do is go to Stat and then Edit. This is the Stat. Where's the Stat button? There it is, right there. So you're going to Stat Edit. And then you're going to enter values into your list 1 and list 2. The first row, you can look at this as the X column. You put that in list 1, and then this row, this column right here goes in list 2. You're going to go to the stat plot menu, turn on the stat plot function, and then use zoom 9 to generate your scatter plot. Okay? Alright, so let's go ahead and generate the data for this set right here. So what we're going to do is follow the instructions. First of all, we're going to go to Stat, the Stats button, and then Edit, option 1. And then in list 1, we're going to enter all these numbers. Okay, so 150, enter 200, 400, 600, and then lastly 1000. And then list 2 is going to be number of gallons used, or your dependent variable. 7, enter 9, and that was 10. 10, enter 19, 29, and 51. Okay, enter. You can go over your entries again to make sure that they are correct. All right, looks good. Now we're done with step 2. Step 3, we're going to go to second function, stat plot. You notice that the stat plots are turned off, so we have to turn them back on. So we're going to turn on stat plot 1, press enter, and then you have on highlighted here, you press enter. We want to use the scatter plot graphing option. Okay, that's what we need here. Now you just press zoom and then 9, and there goes your plots. All right, so now what we want to do is we want to calculate the linear regression. So after generating the plots right here, to calculate the linear regression, you're going to go back to Stat, the Stat button, and then Calculate. It gives you all the statistical functions that can be used to carry out calculations on a data set. Okay, but the one that we're concerned about is linear regression, option 4. All right, linear regression, press enter, enter, And there goes your result. All right. So let's go ahead and write that down. Now, what's the significance of this? A is the slope m, and B is the y-intercept. All right. So we're going to write it down. Note that we were to round the answer to the nearest hundredth, or 2 decimal places. So we have A. Let's bring out the calculator. A is equal to 0.05. So since the number behind the 5 is less than 5, we just truncate those pieces out. We don't have to round up. And then for B, we have negative 0.92, since the number behind the 1 is 5 or greater. All right, so since we have y is equal to ax plus b, our linear equation is going to be what you get when you plug a into this value right here, and then b into that. All right, so let's go ahead and plug them in. You're going to have y is equal to 0.05x minus 0.92. So this is your linear regression equation for the data set to the nearest 100. Okay, go ahead and box that. All right, let's take a look at number 8. It says Max purchased a box of green tea mints. The nutrition label on the box stated that a serving of 3 mints contained a total of 10 calories. On the axis below, graph the function c, where c of x represents the number of calories in x mints. So what we're going to do here is basically use this description right here to generate points. Okay, and then we can draw a graph afterwards. So it says every 3 mints contains how many calories? 10 calories, right? So for 3 mints, this is 3 right here, we're going to go up to this point. How do we know that's the right point? Because when you go up to this point right here, you have to trace it to 10. All right, so for every 3, you go to 10. The next 3, where are we going to go to? 10 plus 10, which is 20. That's the next point right there. Okay? If you're graphing this, all you just have to do is the points. You don't need to graph these arrows and put in there. So for every 3, you go 10 higher. So do you see where the next point is going to be? For the next point, which is 9, if you go up, you're going to go to another 10 more, which is 30, right? So there's the point for 9 mints. And then the pattern basically continues. 12 goes to 40. Remember, we're going up by 3s on the x-axis, and on the y-axis, we're going up by 4s. Okay, so there you go. And then you can see the pattern. If you go up 1, 2, you go over 3. 1, 2, over 1, 2, 3. All right. So what I'm going to do, let me take away all these dotted lines. We're going to now draw the data set. Okay. Well, I'm sorry, we're going to draw the line that represents the data set. What we had to do initially is just draw the points, plot the points using this information. Now let's graph the function. It's going to be a straight line with a slope of 10 over 3. So there goes the line of our function right there. Okay, so this is a perfectly straight line. All right, let's label it. This is known as c of x. C of x. All right, now the next part says we should write an equation of this line. How do you write the equation of a line? We can use y equals mx plus b. All right, so what does m mean? M is rise over run. That's the slope. And then b is your y-intercept. Y-intercept. In this graph, do you see the slope on the y-intercept? The slope is the rise over run. If we count, from here we rise 10, and then we run how many units? 3, right? So in this problem, let's customize it. M is going to be the rise of 10 over the run of 3. And then B, the y-intercept. Where does this graph intersect the y-axis? It intersects the y-axis at 0. So they have it 0. So the equation of this line, we're going to use the format y equals mx plus b. But we can represent y with the name of the function, which is c of x, is equal to m, which is 10 over 3, plus b, which is, 10 over 3x plus 0. All right? Since we're adding 0, we can just write our function as c of x equals 10 over 3x. And that is an equation that represents c of x. Now the last pieces of the problem says that the full box of mints contains 180 calories. Use the equation to determine the total number of mints in the box. So this is basically like an algebraic equation. What we're doing is we're to find, remember, number of mints in the box is x, right? Remember, number of mints in the box is our dependent variable. X, the number of mints in the box is x. So find x when the amount of calories, c of x, is equal to 180. That's the algebraic equation that we're going to solve. We know that c of x is equal to 10 over 3x, as indicated in the other part, part B. Now what we're going to do is plug in 180 into c of x and solve for x. All right, so let's go ahead and do that. We're going to have 180 is equal to 10 over 3x. Now to get x by itself, you multiply both sides by 3 over 10, which is the reciprocal of the coefficient of x, 10 over 3. Okay, multiply both sides by 3 over 10, 3 over 10. 3 goes here 1, 3 divides here 1, 10 divides here 1, 10 divides here 1. All right, now we're going to have x equals, now you notice these two have 0, so you can just divide by 10, and then you do 3 times 18, which is 54. Okay, so there is our final answer, 54.